Hey everybody, Johnny here. In this video, we're going to be doing some procedural modeling, and in doing that, we're going to be using the repeat zone that was added in a few versions of Blender ago. The thing we're going to be modeling is the KALLAX shelving unit from IKEA. I chose this one because it's got a very parametric design. It has a certain amount of cubbies wide and a certain amount of cubbies tall, and we're going to use that to drive the creation of these objects. One of the first things that I do when I'm trying to do some parametric modeling is I try to figure out what are the parameters that I'm going to be adjusting when I want to create this object. So for this shelving unit, we've got a few of these to consider. The two most obvious for this shelving unit are how many cubbies high it is and how many cubbies wide it is. So in this case, this unit would be 4 cubbies high and 2 cubbies wide. For the sake of this tutorial, I'm going to stick with the idea that the cubbies are going to be cubes. So the width and height and depth of the openings are all going to be the same. But I do want to be able to programmatically change that cube size. So we'll just have to define one of these dimensions, like the cube height, the cube depth, or the cube width. These three will be the same in this example. However, you could make it more complex and split these out into 3 separate components. Now there's 2 different cuts of wood in this particular shelving unit. One is the frame for the outside of the shelving unit, and the second is the panels that make up the dividers inside the unit. So we're going to want to determine the thickness of the outer walls and the thickness of the inner walls. We're going to assume that the thickness of the inside shelves is the same thickness as the vertical dividers inside the unit. With these parameters, I think we can go ahead and generate this object. So let's jump into our nodes and get started. Now I'm going to be doing this tutorial in Blender 4.3.2. So as long as you're using that version or newer, you should be able to do all of the things that I'm doing here. If you're using a prior version, I can't guarantee that all of the nodes that I use will be available. So the first thing we'll do is make sure we have at least one mesh object on our screen that we can add a geometry node tree to. You might have the default cube. I have actually got a default plane as my initial setup. It really doesn't matter as long as it's a mesh. Now we'll pull up the bottom screen here and we'll change its type to geometry node editor. With our object selected, we'll hit new and we'll center that on our screen. Now we're using this object simply as a holder to generate our shelving unit. We're not actually going to use this initial geometry. So we can go ahead and cut this line. And then over here in our group panel, if your side panel isn't open, you can always open and close it with the N key. Choose the geometry input from the list, which is the one that has the dots on the left-hand side, and click the minus button to get rid of that input. That way we're not actually sending any geometry to this node. It's going to generate all of it itself. Now let's go ahead and add in the parameters that we're going to want for our unit. In the group sockets, I'm going to add an input, and we'll call this cubbies high, and we'll change the type to an integer. So this is how many cubes tall this shelving unit's going to be. With that selected, I'm going to hit this drop down arrow and choose duplicate item, and I'll change high to wide. So now we have cubbies high and cubbies wide. The next thing we wanted to determine was the overall size of each cubby. And since we're sticking with cube shaped, we just need one value. So I'm going to hit the plus sign and do an input. So I'll double click the name and I'm going to call this cubby size. And since this is going to be a distance, we want to change the subtype from none to distance. Next, we wanted the width of the wood for the outside frame of the shelving unit. Again, we're just going to duplicate this item and change it to frame thickness. It's already set as distance because we duplicated it. And then we're going to duplicate this one more time and make this the divider thickness. So with these parameters in hand, we can start building up our shelving unit. The pieces of this shelving unit are going to be built from cubes. So to begin, we're going to add a mesh primitive cube. Now, we're going to want to be able to control the height, width, and depth of each of these cubes. So we're going to break this vector out into a combine XYZ node. First, we want to create the base of the frame of the shelving unit. First off, we have the Z height of that, and that's just going to be the frame thickness. Next, we have the depth of that piece of wood, which is simply one of the dimensions of the cube that make up the cubbies. So this is just going to be the cubby size. But now we have to generate the complete width of this bottom piece. The bottom piece goes for the entire width of the shelving unit and sits underneath the two outside upright frame pieces. How do we calculate the overall width of this piece? We can think about it this way. On the outside, we have two frame pieces. Then we have the number of cubbies on the inside, and then we have dividers between those cubbies. The number of dividers we're going to have is going to be one less than the number of cubbies we have. So if we have 3 cubbies across, we're going to have 2 dividers. So if we simply multiply these and add them all together, we'll get the combined width of our shelving unit. So let's do that. First, I said we had 2 of the outside frame pieces. So if we take the frame thickness and add a math node and change the type to multiply, we can multiply that by 2, and now we have the thickness that's generated by the 2 outside pieces. Next, we want to create the width of all of the cubbies combined. Again, this is just going to be the number of cubbies wide, and we're going to multiply that by the cubby size. And then finally, I said we'd have the number of cubbies wide minus 1, and that will give us the number of dividers across each layer. So if I take cubbies wide and subtract 1, now I have the number of dividers. I can simply multiply that by the divider thickness. One thing you might want to think about doing when you're creating a large geometry node tree is to come up with values that you might need more than once while you generate this. And these nodes that I've put together here might not be intuitive as to what each one does. However, we can take these and create some temporary variables that we can then reuse later on. First, I'll add together the dividers and the cubbies. When I do this, this actually gives me the complete inside width of the shelving unit. If I drag out from this value and type in R, that will bring up the reroute node as my first choice. With that reroute node selected, I'm going to press Ctrl-J to put it in a frame, and then press F2 to give that frame a name. In this case, I'm going to call it inside width. Then, if we take our inside width and add the outer frames, we'll get the outside width. So now I have 2 very important numbers that I can reuse later on in my node tree instead of having to rebuild this little network over and over again. The bottom piece of the frame is the total width of the shelving unit. So I'll take the outside width and attach that to X here. And then I'm going to attach this cube to my geometry output. At this point, I don't have anything on my screen yet, but that's simply because all of my settings are at 0. So let's go ahead and add these in. Just to begin, we're going to do 4 cubbies high, 2 cubbies wide, a cubby size of 12 inches, a frame thickness of 2 inches, and a divider thickness of 0.5 inches. So there's our bottom plank for our shelving unit. One thing you might also want to do is if you're creating something that's going to be sitting on top of other things, you're going to want the origin to be at the lowest point of the object. If we look at this rectangular solid, we see that the origin is actually in the middle of it. So we're going to want to raise this up half of its height so that that origin point is sitting at the bottom. So if I just want to move all of the points of this cube up a certain amount, I can just use a geometry right set position node. And then I'm going to change the offset of this with a combine XYZ node, and I can just change the Z value here. Of course, the Z value that I want is half of the frame thickness. So I'll take the frame thickness and put it into the Z, and then I'm going to duplicate one of these multiply nodes, drop it here, and by default, it multiplies by 0.5, which is the same as dividing by 2. So now we can see that our origin point is at the bottom of this plank, which is exactly what we were wanting. While we're here, we can go ahead and duplicate this bottom plank and put it at the top of the shelving unit so that we don't have to worry about that later. So how high do we need to go to get to the top of this stack? Let's go back over here and generate another value that we can use later. And that's going to be the inside height and the total height. I'm going to go ahead and duplicate my inputs here just to make life a little easier. Much in the same way, the total height is going to be 2 of the outside frames, the number of cubbies high times the cubby height, and then the number of cubbies high minus 1 to give us the number of dividers on the inside. So we'll take cubbies high, subtract 1, and multiply that by the divider thickness. Adding the cubbies and the dividers together, this gives us the inside height. And then adding in the frames on the outside gives us the outside height. Now that we have our heights, we can go ahead and copy our bottom frame here and then move it up accordingly. So I'm going to take the output of this set position so that we have the frame that's sitting on the origin point. And I'm going to add another set position node. I'll use the offset again, and I'm going to offset this by the outside height. If you're thinking about this, the outside height from the origin is actually going to be on top of the shelving unit. And so this new one we just copied is going to be sitting on top of the total height. So we need to drop it down just by 1 frame thickness to have it set where it should. So I simply need to drop in a subtract node here and subtract the frame thickness. This should now be our new top frame. I'll add a join geometry node and connect it in. So there we go. There's our bottom frame and our top frame. We can now add in our side panels of our frames. This is going to be very similar to what we've already done. We'll have our cube and a combine XYZ for the size. I'm going to duplicate our group input again. So now for our sides, the Y depth is going to be the cubby size. Let's go ahead and join these in so we can see what's happening as we do it. Our width is going to be the frame thickness, and the Z height is going to be that inside height that we had calculated earlier. So I'm going to grab this, bring it down here a bit, and connect it in. The origin of this new cube is also on the bottom of our shelving unit. So we want to move it up down so that it is right in the middle of our shelving unit. Well, we already know the outside height. So if we divide that by 2, that should be the very center of our shelving unit. I'll do a set position node and a combine XYZ so that I can change the Z position. And then I'll plug in half of the shelf height. Now we want to move this from the center of the shelving unit to either side. So we can very easily figure out how far we need to move this over in order to get it to line up with the side of the shelf. I'm going to take the outside width and also divide that by 2. Now, if I plug that into my X component, you'll see it gets me very close, but not exactly where I want to be. You'll see that it lined it up from being centered down the middle to centered down the outside edge. I simply need to push this backwards half the width of my frame. So if I subtract my frame thickness divided by 2, you'll see that this now lines up perfectly. I'm going to do a very similar thing now to generate the other side. I'll take my set position, my combine XYZ. It's going to use the same Z height. Let's join this in. But now instead of adding that width and subtracting half of the frame width, we're going to do the opposite. So here we had the outside width. We divided it by 2, and I'm going to pull that down here to X. It pushed it in the wrong direction, so I'm going to simply multiply that by -1. You can see we're in the same place we were before, and we need to just add in half of that width back again to get this to line up. So here we had the frame thickness divided by 2. We're going to plug that into the X and then add that to that width that we had generated. I'm going to clean up these nodes a little just so that they're a little easier to read. So now we've generated our entire frame. Let's go ahead and put all of what we've done here into a frame node so that we can push it off to the side and not worry about this part anymore. I'm going to select all my nodes, press Ctrl J to join them, and then with my frame selected, press F2 and call this outside frame. Because I'm going to want to reuse these again, I'm going to take these 4 generated values that I created and duplicate them, and then connect them with their previous values. I'm going to take these 4 and hit Alt-P. That takes them out of this group, and so now I can pull them down here. I'll add in my group input node. And now I'm ready to move on to start adding my dividers. So for this next section, we're going to start building the dividers inside of the shelving unit. And the first ones we're going to do are going to be the ones that are horizontal, that will be the rest of the shelves on the inside. For this part, we're going to use the repeat node. So I'll go ahead and add a repeat node group. Now, the repeat node group is a fairly simple node group to understand, but sometimes it can be a little tricky to use. So here's what we're going to do. The repeat node group has a geometry input. this is going to be the base geometry that is going to start inside the node group. For our purposes here, we're not actually going to have any geometry starting inside the node group. The node group itself is going to generate all of its own geometry. The other bit are the number of iterations. This is how many times the repeat zone is going to loop through. Finally, we have the repeat output node, and this node has a geometry input. So here's how this works. If the iteration count is 0, whatever is coming in the geometry input here is going to come out the geometry output on this side, as long as it's connected on the inside like this. If there's more than one iteration, whatever goes into the input of the final node of the repeat zone gets put back in the geometry output of the entry point. So if there's 2 iterations, the geometry coming in will follow this path, will get here, and then for the second iteration, whatever comes out of this will come out of here again and go through the loop again. Finally, when the number of iterations is done, whatever is here on this input is going to get sent out of the group. So let's see how we can use that to repeatedly create some geometry. First, let's create a cube that will represent one of these horizontal dividers. So using the cube primitive node, I'm going to attach a combine XYZ, and then we'll plug in the values that we want to generate for our shelf. Since this is going to be one of the inside dividers, we'll use the divider thickness for the Z. The Y value, or the depth, is going to be driven by the cubby size, and the width of this piece is going to be the inside width of our shelving unit. I'm going to go grab our output node and bring it down here. So I'm going to join the output of my repeat node with all the other geometry that we've already created. If I connect the cube that I've created straight to the output, you'll see the shelf that we've created sitting here where all the other cubes had started. But instead of connecting it here with all of the final outputs, we want to connect it inside of our repeat zone. So I'm going to grab a copy of this join geometry node and bring it inside my repeat zone. And then I'll connect my cube to that. So now, with the iterations here set to 1, let's see what's happening. We have no initial incoming geometry. Then that empty geometry heads to this join geometry, where it has a cube added to it. It then heads to the output node, and since there's only one iteration, that cube that we created is sent to the final output. So we're going to want to move this shelf up into its proper position. There's a couple of different ways we could attack this problem. We could move this shelf and set it on top of the bottom one here, and then move it up 1 cubby height. Then if we had additional ones, we would move it up a cubby height, then a divider height, and then a cubby height, and a divider height, and so all the way up the shelving unit. Another way to attack this would be to move this up to the top of this shelf, but leave the center point at the center of the shelf. Then using the inside height, distribute them evenly. This method seems to work well for me, so I'm going to go ahead and use that particular method. So the first thing we'll want to do is move this up so that instead of being centered on the bottom of our outer shelf, it'll be on the top. So we'll just want to move this geometry up 1 frame thickness. To do that, I'll use a geometry set position node, and for its offset, I'll do a combine XYZ, and then connect that to the frame thickness. So now we have this centered at the bottom of the inside height. Now we need to calculate how much more we need to add to this on each iteration. If we have just one shelf, then we have no inside dividers. If we have 2 shelves, then we have 1 inside divider, and it's going to be halfway up the inner height. So if we divide the inner height by the number of shelves, we're going to get the increments for each shelf. So if I take the inside height and I divide that by the number of cubbies high, that's going to give me the distance between each divider. I'm going to move the cubbies high down to 2 just so that we can see what's happening here. So right now, I've got the inner height and I'm dividing it by 2. That should give me the very center of the inside of my frame. So I'm going to add that to my frame thickness. So first, the frame thickness, moved the shelf up to here, and then adding half of the inner height, moved it up to here. Now that we have that case taken care of, let's see what happens if we add more shelves. So I've moved it up to 3 cubbies high. So now the inner height has been divided by 3. And you can see here that the shelf has been moved to 1/3 of the way up the shelf. But the second one hasn't been moved up to 2/3. So how are we going to do that? So in the first iteration of this repeat zone, we're going to want to move the first divider we create up 1/3. And then on the second iteration, we'll want to move the second one up 2/3. A thing to keep in mind with the iteration number is that the iteration numbers are 0-based. So the first iteration is actually iteration 0. So if we take our inner height that we've divided into the correct amount of parts and multiply that by the iteration number plus 1, so the 0th iteration, we'll multiply that by 1, which would give us 1/3. The number 1 iteration, which is actually the second, we add 1 to that. That gives us 2 times it, gives us 2/3. So let's go ahead and do that. If I take my iteration number and add 1 to it, and then I multiply our divided space by that number, and then we also move our iterations up to 2, so that we're making 2 shelves, we see that they're spaced out correctly. Now, of course, we're going to want to drive the iterations number here dynamically. When our cubbies high is 3, we only want to create 2 dividers. So we're going to set the iteration number to the number of cubbies high minus 1. So now, if I increase the number of cubbies high, the internal shelves should increase. Now that we've created the horizontal dividers, what we only have left to do is to create the vertical dividers. Now we do want this to be built in the same way that the actual KALLAX units are built. So we're not just going to create a single piece of wood that goes all the way straight down through the middle. Instead, these units are built with individual dividers in each level. So we're going to need to create these like this. And if it's wider, there's actually going to be 2 like this on every level. So how are we going to do that? If you've done any programming, you might be familiar with the concept of a nested for loop. This is the same idea of what we're going to do here with repeat zones. For simplicity's sake, I'm going to make a separate repeat zone for these upright dividers. You could do what I'm going to do and merge this in with my existing repeat zone here, but just for clarity, I'm going to do it separately. In a lot of ways, this is going to look a lot like our horizontal dividers. Here I'm just creating my inputs again, just for cleanliness' sake. First, let's go ahead and make our cube that's going to be the size we need for the inside vertical dividers. I'm going to grab a few of these nodes that I had before just to make my life a little easier. Now, let's talk about what size this piece of wood needs to be. The x value of these, since they're going to be standing straight up on their end, is going to be the divider width. Again, the depth will be the cubby size, and the height will also be the cubby size. Let's create our first repeat zone. This one is going to create the multiple shelves along one vertical shelf. So for the iterations going along this way, we're going to want the amount of dividers is going to be one less than the cubbies wide. So we'll do this, cubbies wide minus 1. That will give us our iterations for going across. We'll add a join geometry and connect in our cube inside the repeat zone, and then we'll tie the output of the repeat zone into our final output. If we want to use the same sort of idea we used for the horizontal shelves, we can move this cube over here to the left side of our inside width, and then space it out like we did with the others. I think that's going to be the quickest and easiest way to do it. So we're going to want to subtract half of our inner width to get it over here. And since I want this value to be negative, I'll actually divide this by -2. I'll put that in the X offset. And you see that gets us lined up the way we want. We're not going to worry yet about our Z height. We're just going to worry about spacing them out from left to right at the moment. Again, we're going to want to take our inside width and divide that by the number of cubbies. Then we'll simply multiply that by whatever iteration we're on plus 1, like we did before. And then finally, we'll add that back into our movement of half of the inside width. And we'll check to make sure that works properly, which it does. Now that we've done this, we want to repeat this for each horizontal shelf space. I'm going to give myself a little more room here. And I'm going to add in another repeat zone. This repeat zone is actually going to be on the outside of our first repeat zone. So to wrap this around our existing repeat zone, we're going to take the output of our initial repeat block and plug that into the input of what will be our inner repeat block. When you do this, you'll see that the repeat zones go away for the moment. They will come back when we're done hooking this all up. Then we're going to remove our link from the end of our old repeat zone, and we'll connect that to the output of our new repeat zone. You can see now that our first repeat zone has now been encapsulated by our new repeat zone. And I'll connect that back to the full output. Next, we're going to want to set the iterations for our outer repeat zone. That's going to be the number of cubbies high exactly, because we're going to want a set of these dividers for each cubby, not for each set of dividers. The last thing we need to do is determine how we're going to set the height of our new dividers. My plan is to move them up so that they're centered at the top of our outer frame here, and then add half of a cubby height. That will put them in the correct position for this first iteration. So let's do that to start. We're going to be adjusting the Z input of our original combine XYZ. I'm going to grab a copy of my inputs just to keep things clean here. I said we wanted the frame thickness And then we want half of the cubby height. And then we'll add that to the frame thickness. And now for each iteration, we'll want to add one cubby height and one divider height. This is where we can use the fact that the first iteration number is 0 to our advantage. If we take the iteration number and then multiply that by the cubby size plus the divider thickness, and then add that back into our Z height, you'll see that we get what we were looking for. Now, one thing we can do to this final product to make it look a little nicer is we could add a bevel modifier, dial down the bevel a bit, and then of course we can change our settings to get different size shelving units. One last thing we might want to do is add the ability to set a material from our modifier panel. We can do that pretty easily, especially since all of the pieces are going to be the same color. If we go just before our final output and add a set material node, and then add our group input, we can connect up the material. Now, if I were to generate a material, I can simply assign it there. Now, I would suggest if you've gone through the process of generating a large node tree like this, or even something larger, that you go back through and do some organization. Put things into frames, label those frames, so that when you come back to this later and you don't know which group here takes care of the horizontal dividers, you would be able to find it. So in this case, I might come in here like this, grab these nodes and hit Control-J, select the frame, hit F2 to rename it, and put horizontal dividers. And then here, put vertical dividers. So in this tutorial, we tried to think about ways to approach procedural modeling. You want to break things down into their components, and you want to try to determine what parameters you're really going to need in order to make them go. Then, as you build, if you can generate values that you're going to reuse a bunch of times, make sure to mark those so that you can always go back to them instead of recalculating the same things over and over and over again. Lastly, we wanted to check out the repeat zone and how we can use it, and how we can even have nested repeat zones to do things in more of a two-dimensional way as far as us generating dividers both horizontally and vertically at the same time. As I've done in the past, this source file will be available on my Patreon page. You can go there to subscribe and to download this and past source files that I've done with my different projects. If you've made it this far, A, I'm really impressed that you stuck with me, and B, I just want to thank you so much for watching. We're going to wrap this up for now. I hope this tutorial inspires you to make something awesome, and until next time, I'll catch you later.